Good morning, Physics 40S class. Here you thought that you were going to get away with a day that Mr. Stoesz isn't here and you're not going to have to do any work or take any notes. Maybe you thought you were going to watch a video, possibly even one of those Elegant Universe videos. Well, Braxton, sorry to disappoint you. There's wonderful technology here. I'm recording this currently at home at 12:30 at night, the day before your class. So here's a couple of examples for you in order for you to understand the coefficient of static and kinetic friction. And yeah, take out your notes because we're going to do two examples. And then there is going to be some time for you to work on some textbook problems that your substitute teacher will post on the board after this lesson. Alright, so I'm going to write out our first example here. Now, I have used this program a few times, but hey, I'm still learning, so let's see how this works. We have a 5 kilogram box. Oh, no, it's not working already. Gotta love that, eh? A 5 kilogram box is on, oh man, can't even spell, is on a surface. The coefficient of static friction is 0.60. Of kinetic friction is 0.55. If I push the box horizontally with 28 newtons, how much force will friction provide? Okay, let's see if I can, there we go, move that around a little bit. There's our question. Give you a moment to finish writing that down. Now, here we're being given the coefficient of friction for both static and kinetic. We're told how much force I am providing. We know the mass, we can figure out the normal force. And since I'm supposed to find how much friction will be, I really need to figure out if I'm going to be in a static situation or if I will be in a kinetic situation. So really I have to figure out how much friction can both static and kinetic provide and compare that with my 28 newtons in order to figure out what kind of situation am I actually in. So, Rachel, I know you love to draw things out, so we're going to do a very basic drawing here. Let's see how well I can draw with this program. There's my surface. Oh, that's pretty flat. We've got my box. And then if I start putting in my forces, and I believe I can do forces or arrows like this. We'll see how well this works. Okay, move that over. This will be our force of gravity right here. This is Fg. So then we know that there is also going to be Fn of equal size, and wow, those arrows are really big. So we've got Fn. And then, of course, there is the force that I am providing of 28 newtons. So we'll call that an applied force, Fa. And then there's the force of friction, and we don't know the value of the friction. We know it's opposing Fa. It might be larger. It could be smaller. but we got to figure that out. So what I'm going to do is I'm first of all going to find out what the force of friction is for both the static situation and for the kinetic situation. And from there we'll be able to compare it to the 28 newtons. So I'm just going to zoom out here a little bit so that I got a little bit more room to work with. And I hope I can write this legibly so you guys can read it. So if I use my equation of coefficient of friction, we've got mu equals force of friction divided by force normal. And what we're first of all going to do is the static friction here. And if I rearrange, I know I'm going to get force of friction static equals mu Fn, and that's static as well. We can place in our values. We've got 0.60, make that point a little more obvious, and multiplied by Fn, which we know is equal to Fg, so 5 times 9.8. Alright, those points I have to make more obvious. So when I calculate that all the way through, I'm going to get 29.4 newtons. So this right now is greater than the 28 newtons. So it could be that we're actually could be in a static situation, or it could be that we're in a kinetic situation. So let's check out our force of kinetic friction. So if I do that here, force of friction kinetic will equal mu k times F n. And we'll have 0.55, and I can see I need to move this over a little bit here. Times 5 times 9.8, and when we do that, I'll round that off to, I get 27.0 newtons. Alright, so here's our two values. 28 newtons is less than this, but greater than this. We're going to assume that this box started at rest, which means that it started off in a static situation, and at no point was I able to reach greater than what static friction can provide, because remember that this value here technically is a maximum. So technically our equation here is less than or equal to 29.4 newtons. So since I'm providing 28, I never was able to overcome this and actually cause it to start to move. So we're still in a static situation. We're not in a kinetic situation. So that means that if I'm still static, that my applied force has to be exactly cancelled out. I'm not moving it, I'm not accelerating it. So in that case, if I have force applied is equal to 28 newtons and my net force is 0, that means that the force of friction static also has to be 28 newtons. It's in the opposite direction, so then technically what I need to do is I need to understand that this is a negative over here, and that the force of friction static is equal to negative 28 newtons. That's my answer, and so I will then box that. So hopefully that clears up how that idea works, and that what we're doing is we have to determine what kind of situation we're in. The static friction is always tricky because the calculations you come up with it, you have to understand that's a maximum. It can be less than that, depending on the situation. So we're going to try a second example here. I'll start a new slide so you guys can get that ready. Okay, here's our second example. And when you first look at it, it's going to look very, very similar to the previous one. A 5 kilogram box is on a surface. Yes, we like to use boxes in physics. The coefficient of static friction is 0.60, same as the previous question. Of kinetic friction is 0.55. That's also the same. But now I'm going to be pushing with 30 newtons, not 28. And I want to find what the force of friction is, what the net force is, and what the acceleration is. So the fact that I'm asking about net force and acceleration gives you a clue that probably the force of friction is not equal to my applied force. It still could be, and then in that case the F net is 0 and the acceleration is 0, and this becomes almost a pointless set of questions. But likely we're looking at a situation where friction is not canceling out my net force. So you can see that I've got the diagram on the side there. And again, if I start drawing in my vectors, I'm going to draw all the vectors in first. Here is my force of gravity. And I will have my normal force as well. I have my applied force. And I also have my frictional force. And again, it's the frictional force that I do not know what the size of this force is. So I'm going to quickly just label these. I'm going to try something a little bit different here. We'll go like this. We'll change that to red. This is FG. Ooh, ooh. Try to move this around here. There we go. And this here is Fn. And I apologize that the n is not as lowercase as the f. I am still trying to figure out how to do that with this program. And we've got Fa over here. And then, of course, we've got FF. And at this point, we don't know if it's static or kinetic again. Hopefully you can kind of get a sense as to what it is. So, since the mass is the same, the normal force will be the same, and since both the static friction, the coefficient of static friction and the coefficient of kinetic friction are the same as the previous question, we already know what those calculations are. We can go through that again, but we know what they are, so I'm going to write them in. So we have those values. So we know that the force of friction static is equal to 29.4 newtons. I bet you that's a whole lot easier to read. And the force of friction kinetic is equal to 27.0 newtons. So now when I take a look at this, I am pushing with 30 newtons. So my applied force is equal to 30 newtons. I now have to determine, am I going to be in static or kinetic? So since I'm pushing with 30, right here, the friction of static can only provide 29.4. So what I've done is I've overcome static friction. I am larger than that value, which means now I have accelerated the object. But because I've accelerated it, I am no longer in a static situation. The box is going to be moving in relation to the ground, or in relation to the surface, which means that now I am automatically in a kinetic situation. So I'm able to answer how much the force of friction is already, because I know that I'm now in a kinetic situation. I cannot be in static, because static is not great enough to overcome or to cancel out, I should say, my applied force. So the first part of the question is that the force of friction, oh, let me not do that there, let me move that around. Oh, come on. Okay, let me try it over here. The force of friction is equal to the force of friction kinetic, which is equal to 27.0 newtons. And there's not really an equation that I have, or a work that I have to calculate. That's all based upon the logic of the situation. This is really what I need to show that I've done for this situation. But now I can move to the second part of the question. So this part here was part A, and now I can move to part B, where now I'm trying to find the net force. So we know from previous classes that the net force, F net, is all the forces combined. We know that Fg and Fn will cancel, so all we have left is the applied force and the frictional force. Because we know that friction is opposing the applied force, I'm going to make the frictional force negative, force of friction, and I know it's in a kinetic situation. So when I then take a look at how to do this, I place in my values. My applied force is 30 newtons, my force of friction is 27.0 newtons, so my net force then becomes 3 newtons. That's my answer for part B, 3 newtons. It's a positive value, which tells me that I'm going to be accelerating in the same direction as my applied force. So now, part C is the acceleration. And this goes all the way back to grade 11, where F net is also equal to ma. I have the net force, so I'm going to have to rearrange this. Then I'm going to have that the acceleration is equal to the mass, F net divided by the mass. Place in my values. I think I'm going to draw this now. The acceleration will equal to the F net, which we just figured out is 3. The mass is 5. And then 3 divided by 5 gives me a value of 0.6 meters per second squared. And that's my answer. There we go. Oh, I guess my previous text is gone. That's really weird. So hopefully this is going to be enough information for you to try the textbook questions. You have probably around half an hour for you to finish these questions. We'll go over them on Tuesday's class. Monday is no school. Woo-hoo! And hope you guys eat lots of turkey. You get lots of melatonin. You sleep on the couch with your belly full of turkey and mashed potatoes and stuffing and Jell-O, because there always has to be Jell-O at Thanksgiving, you know. Hopefully, someone has made coleslaw for you. I'm hoping that my mom will make me coleslaw on Thanksgiving. But we'll see. Otherwise, I'll have to make it myself. Hope you guys have a great time, and hope this worked for you. And yeah, have a great weekend.